In this problem, we have f of x equals 1 half e to the negative x over 2, such that x is in the domain 0 to infinity, including 0. We want to find the probability that x is less than or equal to 4. To find this probability, we need to set up an integral. And with this integral, we need to set up our limits of integration. Since we know x has to be less than or equal to 4, and x can go all the way up to infinity, then that means our top limit is 4. And again, because we know x is less than or equal to 4, that means it could go all the way down to negative infinity, but we're told x can only be between 0 and infinity, including 0. So that means it can only go down to 0. And we're taking this antiderivative of 1 half e to the negative x over 2 dx. Unfortunately, we cannot take this antiderivative yet. We have to use a u substitution to find this antiderivative. So in order to do that, we have to find out what u is. And u is whatever we need to substitute into this problem to change it to something we can take the antiderivative of. For instance, we can find the antiderivative of e to the u, not e to the negative x over 2. So to find that antiderivative, we need to let negative x over 2 equal our u, which means du, or the derivative of u, would be equal to negative 1 half. That's because the derivative of anything times x, or x divided by any constant, either way you want to look at it, is just the number that's in front of your x. So really u is negative 1 half x, if you prefer to look at it that way, and that makes it easier to see that the derivative is just the negative 1 half. But remember, whenever we take the derivative of u, we always have to include this dx here. There's a slightly complicated explanation there, but the too long didn't read essence of it is the derivative of u isn't du, it's du over dx. So to move this dx to the other side, we'd have to multiply it, so we get negative 1 half times dx, and the dx goes away here. Okay, so with that in mind, we can now substitute these in, but we don't have a negative 1 half dx in our problem. We have a positive 1 half dx. So we need to change this to a negative. And when we change that to a negative, the only way that we can do that without changing the problem is by multiplying a negative to the outside of the problem. So that gives us negative times the integral of e to the negative x over 2 is just e to the u. And negative 1 half dx is just du. And now from here, we need to plug in our limits of integration, 0 and 4, into our u. We call these u1 and u2. Doesn't matter which order you do them in. You could also call them the upper limit and lower limit. We're just finding our new limits of integration in terms of u. This way we don't have to go back to the x's when we're done with the problem. So for the upper limit, u1, we're plugging a 4 into our equation u equals negative x over 2, meaning x will be replaced by a 4, which gives us negative 2. And u2, our bottom limit, was a 0, so we're plugging a 0 into this, which gives us negative 0 over 2, which is just 0. So we get the negative integral from 0 to negative 2 of e to the u du. And now from here, we know that we have a rule that says whenever you have a negative on the outside of your integral, you can flip the integral's limits, meaning the -2 will go in the bottom and the 0 will go in the top. And that cancels out this negative. And we get the integral of e to the u du. And now, after all of this, the u substitution is done. We can take the antiderivative of e to the u. The antiderivative of e to the u is itself. It's just e to the u, because the derivative of e to the u is e to the u. And this is being evaluated from -2 to 0, which means we're going to plug these values in. We have e to the 0 minus e to the -2, which gives us, when we plug this into a calculator, 0.8647 after rounding to the nearest 4 decimal places. And because this is a probability, we say that the probability that x is less than or equal to 4 is this 0.8647, which we can convert to a percent, giving us 86.47%.